Hi everyone, this video is going to go through question number 6 from the 2019 AP exam. So here we're given information that functions f, g, and h are twice differentiable functions with g of 2 equals h of 2 equals 4. They give you an equation of the line. They're telling us that's tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. All right, so the first question here is asking us to find h prime of 2. So for h prime of 2, what we have to recognize is when we have h prime of 2, that's really representing the slope of the line tangent to h at x equals 2. Well, they told us that this equation here is the tangent line to the graph of h at x equals 2. So if I'm looking for that slope, I'm just going to grab it right from the equation, and I know that h prime of 2 is equal to 2/3. And you're done. So there's no work to be doing there. It's just interpreting the meaning of h prime of 2 and knowing that you can get it from the equation of the tangent line. So that question is just 1 point. All right, for part B, it says let A be the function given by this function A of x. They want you to write an expression for A prime of x and then find A prime of 2. So let's go ahead and do that. So A of x was 3 times x cubed times h of x. So here I can see I'm going to use product rule. I've got two functions, 3x cubed and then h of x. So A prime of x, I'm going to do 3x cubed times h prime of x plus h of x times the derivative of 3x squared, or 3x cubed, excuse me, is 9x squared. So then to evaluate a prime of 2, I'm going to substitute 2 for x. All right, so let's see what we've got here. 2 cubed is 8 times 3 is 24. H prime of 2, we just did that in part A. We know that's 2/3. H of 2, they told us here that h of 2 is equal to 4. And then 4 times 9 is 36. So I can just use my calculator to simplify that. Obviously, everything on this year's exam, you'll have access to a calculator. So let me do that quickly. Okay, and I got 160 there for a prime of 2. So for this one, they gave you 2 points actually for just the expression for the derivative, so knowing to use your product rule, and then 1 point for getting that answer of 160. All right, part C. Now this is a big one and there's a lot going on here. All right, they're telling us the function h satisfies this equation for h of x for x not equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. So if they're telling me L'Hopital's rule applies, I'm thinking that there was some kind of indeterminate form, and that's going to play a big role in a second here. So it's saying to use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. All right, so let's see what we know here. It's saying to use the limit as x approaches 2 of h of x. So we've got to think about what that might be. So I'm going to kind of start there. The limit as x approaches 2 of h of x. And here I'm going to use something that they told us up above. So they told us that these functions, including h, are twice differentiable functions. So I know if h is differentiable, since h is differentiable, h is continuous. Okay, remember, once I know a function is continuous, I know the limit of that function at a specified value is equal to the function value. So in other words, that means I know that the limit as x approaches 2 of h of x must be equal to h of 2. That was our definition for continuity, that the limit at that value is equal to the function value. Well, the nice thing here is we know what h of 2 is. They gave us that information, and that's equal to 4. So this is going to help us out because we now know the value of the limit as x approaches 2. I'm going to slide my paper here. Sorry for the shuffling. Okay, so now we know that. So now we have to work on finding f of 2 and f prime of 2. All right, so let's do this. So I know that this limit is 4. We also know that h of x was the same. H of x was defined as this function, so now I know the limit as x approaches 2 of x squared minus 4 all over 1 minus f of x cubed. That limit is also equal to 4. Because that is the function. Sorry, I keep not showing this. That is that function. Now, they told us something here. That limit can be evaluated using L'Hopital's rule. So let's check that out. If I tried to plug in 2, I know generally when I'm evaluating the limit, I'm always going to try to substitute that value first. So if I try to plug in 2, let me go down here. X squared minus 4 over 1 minus f of x cubed. If I substitute in 2, I'm going to get 2 squared minus 4 is going to give me 0. Now, in order to be able to use L'Hopital's rule, that must mean I'm in an indeterminate form, which means my denominator must also be equal to 0 when I sub in 2. So here's what we have to do. We're going to set up an equation here. We're going to say 1 minus f of 2 cubed is equal to 0. And again, that has to be true because in order to use L'Hopital's rule, I need to have an indeterminate form. So that meant when I plugged in 2 here, I should get 0 to get that indeterminate form. And this is what's going to allow us to solve for f of 2. So now I'm just going to move this over. I can say f of 2 cubed is equal to 1. If I take the cube root of both sides, now I know that f of 2 is equal to 1. So we've got one of our values. All right, so now we have to solve for f prime of 2. That's the last piece here. So here's what we're going to do. If we're in the interest of space here, I'm going to do this. I'm going to take this limit, x squared minus 4 all over 1 minus f of x cubed. Since we need L'Hopital's rule to evaluate this limit, I'm going to go ahead and apply that here. So since this indeterminate form was 0 over 0, we're going to apply L'Hopital's rule. So L'Hopital's rule says we're still taking that limit, but we're going to take the derivative of the numerator. That's going to give us 2x, and we're going to take the derivative of the denominator. Now in this case, that's going to be, the 1 is going to go to 0. Here I'm going to have negative 3. My inside function is going to stay the same. I'm going to decrease my exponent by 1. And then I'm going to multiply by the derivative of the inside, which is f prime of x. All right, so now, again, we know that limit value is equal to 4. So here's what I'm going to do. I'm just going to put that in parentheses. Here's what we're going to do. Let's go ahead and substitute in now. Actually, let me get rid of this right here. We'll do that in a minute. All right, so now I'm going to try resubstituting. So let's try substituting in 2. So I'm going to do 2 times 2 is 4 in my numerator. I've got negative 3 times f of 2 squared times f prime of 2. Well, if I simplify that a little bit, I know that f of 2, we found out that was just 1. So I've got negative 3 times 1 squared times f prime of 2. So I have 4 over negative 3 times f prime of 2. Now remember, we established before, we know the value of this limit is equal to 4. So now I can set this equal to 4 and solve for f prime of 2. So let's see what we get. We can do 4 equals 4 times, I'm just going to do negative 3 times f prime of 2. I'm going to divide by 4 on each side, so I get 1 equals negative 3 times f prime of 2. And then f prime of 2 is going to be negative 1/3. So that is definitely a pretty meaty problem. They're asking you to make a lot of connections. So here's one where I'd say definitely watch the video, try it out, but we can talk through this one if you need kind of help pulling all of those ideas together. As far as points, they assigned a point for knowing that the value of this limit was equal to 4 using the information that we were given. There was, let's see, I think a point for f of 2, a point here for applying L'Hopital's rule, and then a point for finding f prime of 2. All right, so that's it for this problem, but again, it's probably one we may want to revisit as a group if you've got questions. All right, thanks for watching.